Hello, good morning, good afternoon, and good evening, based on which zone you are watching me from. Uh, my name is Anuj Mohan. I'm an Oracle ace, and I'm founder of Oracle 12c. I work for data intensity as technical account manager. I've done a few certifications, and this morning we are going to talk about 12c release 2 in memory options to avoid performance problems. As I said, I belong to Oracle ACE program. So here is some information about ACE program. And if you are into community and sharing stuff, then you should be trying and evaluating your options to join the program. This is advocacy program which promotes sharing, and it's a kind of you get a kind of recognition also. So this is a good stuff. You should be trying it if you are in community and sharing stuff. This is something about the data intensity. So we are into a broad range of database solutions. We support data on a vertical. As you see, support databases, applications, and BI analytics. And we have a delivery model of like a professional services, managed services. We have our own cloud offering. So we, are, we do pretty much full stack service for the database platforms. And this is how we support our global customers and our global presence. So this is how we support our customers on 24 by 7 basis. We have offices in India, Russia, um, UK, and multiple offices in United States. Right. So with that being said, I'll start with today's agenda. And in the agenda, I'm going to talk about a quick introduction of in-memory option, how you configure it, how you populate it, in in-memory advisors. And then at the end, I'll talk about some new features which were introduced in 12c release 2, which could be really interesting and helpful uh, in in avoiding your performance related problems. So with that being said, let's start with the introduction. So 12c release 1 uh, came with a lot of new features, but after that, the patch first patch set came, and it brought in some brand new features on top of 12c release 1. One of them was like advanced index compression. Another feature was approximate count distinct. So if you are doing a aggregation, and you can neglect a little bit deviation. So if you're looking for like a 99.2% accurate results, then this is the way to go, and you get like a lot of performance benefits when you're doing a approximate count distinct rather than doing an exact count. So then after applying, you get the full uh, automatic big table caching, and this is for like if you're doing a serial query on a table, and there are two requirements. You need to set an init parameter db big table cache percent target, and value for your parallel degree policy must be auto or adaptive to use this feature. Then there was a full database caching. By default, it is there, but you can force it also. Database checks if the SGA is big enough to accommodate the whole database, it will cache it. And if you want to force it, you can force it also. And the way you do it, like you shut down your database, startup mount, and do a alter database force, full database caching, and then open, and it will do it for you. Then the JSON support, that was a new big feature. PDB containers. PDB containers was an interesting feature because in 12c release 1, PDB were introduced, but these PDBs were like kind of solos, and they are in their own world, but you cannot aggregate data uh, among the PDBs. So if you want to aggregate data between two PDBs, you will not allowed to do so. But with the PDB containers clause, you are allowed to aggregate data between two PDBs and get a superset value. So that was one thing. And then another feature came was PDB subset cloning. So if your PDB is very big and you want to do a cloning of a subset of a PDB, you are allowed to do so. Then rapid home provisioning. So like a zip installer kind of thing. You just extract the file to the directory where you want to install, and then you run a configuration rather than running an installer. So this was a nice feature, and it has a lot of benefits if you're a large environment and you have to do a lot of installation. If a large environment, you can have your like gold copies uh, and manage the provisioning like really quick. Then there was a partitioned external tables that was new. And at the end, I'll talk about like the real big new feature came was in-memory option. So let's talk some more on in-memory. What is in-memory? So traditionally, if you see, the data is stored in a row level format, uh, and the new in-memory format was a column level format. And until the in-memory option, you had to choose between row level format or column level format. You've been given some option if you are using um, Exadata, but where you can use like a hybrid nature. But the true in-memory came with this patch set where you will have an option to store your data in a row level format, the traditional format where data is stored in disk or in the memory, but the column level format and what happens is usually like OLTP queries where you do a insert and update on the row, but the analytical queries you retrieve, but you do not retrieve like the whole row. Uh, rather you just retrieve a few columns. And if you have to retrieve a few columns and you are retrieving the whole row, then it's a lot of cost for and it causes slowness. So, on top of that, when you store rows in a columnar format, so what happens is that the similar data is tightly packed together, and you get a compression with the in-memory option, and it improves the access efficiency and reduces the memory traffic uh, because if the data is compressed, then you're handling less data than the traditional way, right? So So database Oracle will be responsible for managing transactional consistency between row level and column level format, and data will be compressed, right? Um, some in-memory column store facts. So if you're using or you're planning to use in-memory column store, you do not need to make any application change. Your application will run the same it was running in non-in-memory architecture. You do not need to tell optimizer something. CPU knows if it has to use in-memory column store or buffer cache, and it knows which one is efficient. And Oracle will maintain 2 copies of data, buffer cache and in-memory column store simultaneously. There is a new background process, Aura W001 underscore RTL, which populates data in memory column store. And the parameter in memory max populate servers define how many processes will be involved for populating in memory column store, and its default value is effective CPU thread count by 2. So the half of the effective CPU thread count, that's what it will use if you do not define it. And there is some good read here. You'll be getting my presentations. If you want, send me an email and I'll be sending a presentation. It has a lot of code and links which you should be able to use. All right. So with this, we'll talk about how we configure in-memory column store. And the answer is there is no specific installation steps required for in-memory option. If you are database 12c release 1, you have to apply the first patch set. There is a doc ID which you need to refer to apply that patch set. If you are 12c release 2, it's automatically installed. So that is installation. How you initialize? You need to initialize you just need to set a init parameter which is called in-memory underscore size. It will not activate by default. You need to set in-memory size parameter and restart the database to activate it. Ideally, you should, if you are planning to use this feature, you should increase the size of SGA, the amount you want to use for your in-memory column store. So please do not steal memory from SGA for in-memory column store. Ideally, it should be added. And once you set this parameter and start your database, you'll see that there will be new row adding to your start instance in memory area, right? Okay. And so in your SGA, there is a new in memory area will be allocated. Another way of showing. And if you talk about the in-memory area, basically it's a two areas constitute to make an in-memory area. One is called IMCU, which is in-memory compression unit, and it stores the compressed data. And the other one is called SMU pool, which is snapshot metadata unit. So the snapshot metadata unit stores information about the compressed units, and they constitute together as an in-memory area, right? So as I said earlier, do not steal memory. If you want to initiate an in-memory column store, then increase the SGA. The minimum size is 100 MB. So SGA target, you should be having like existing SGA target plus in-memory size, which you want to increase. And if you are using Oracle RAC, then please add 10% extra for the RAC overheads. There are some directions for PGA target also. So PGA target is equal to parallel max servers plus 2 GB to define. And there is a good note you want to review before you decide to move for this. So once you initialize your in-memory column store and you start and just check like memory parameters, this is what it will look like. And I'll just take a moment to discuss some about what these parameters are. So like high shared memory address. This basically not a big parameter, but it's specify like what is the starting runtime address for your system global area. In-memory ADG enabled, and it says like active data guard media recovery needs to retrieve in-memory objects when applying redo logs. So basically this parameter says that when you're applying redo logs, you need to retrieve in-memory objects also. And so this is when you are using your in-memory column store on active data guard size, which was 12.2 feature. In-memory clause default, and what this parameter is. So in-memory clause default will take two parameters, in-memory or no in-memory. So if you install the patch and you did not start it, then the value will be no in-memory. And when in-memory yes, then it will ask for the compression clause. So the compression clause values are if you want to use it or you don't want to use it. So you don't want to use it, then you say no mem compress. And if you want to use it, then you say like mem compress for. And if you decide to choose for a compression, then you'll have an option to choose between DML, query low, query high, and capacity low and high. So those will be the options to choose for compression. Then when you use option in memory, then you'll have an option to define priority: low, medium, high, or critical. There is some more reading here about this. Um, so by default, if you have like low, medium, or high priorities, by default it will not start populating unless you have a priority of critical. So if you want that the table should go to in-memory column store immediately, then you want to keep the priority as critical, or else you keep any other priority and it will start populating it based on first access. In-memory expression uses another important parameter. So it controls if you want to use in-memory expressions. So if you set this parameter, if you make it as enable, then you should be able to use in-memory expressions, and the values are static only, dynamic only, or enable or disable. If you just set it up enable, then if you're creating the expressions automatically, if you're creating expressions explicitly, then you'll be able to use it. If you use dynamic only, then it will search for the candidates for expression. For now, I've been using as an enable, but there'll be more research area if you want to use a dynamic only. And there is some good reading here. So in memory force, that's another interesting parameter. In memory force, it specifies whether table and materialized views that are specified as in memory are populated into in memory column store. And so if you do a in memory force is equal to default, that means it will go and populate. If you say off, then it will not. In memory max populate servers, we talked about this parameter. This parameter says like how many servers will be used for populating your in-memory column store. And by default value is half of the effective CPU count. And there is some more reading on this. In-memory query. This is another interesting parameter. So what you do is the values it takes is enable and disable, and if you disable it, like on a session level, it will stop using in memory. So if you are showing it to your customers, you can play with this. And I have some slides to talk about this more in following part of the presentation. In-memory repopulate servers, and this parameter says like how many servers you'll be using to repopulate in-memory column store. In-memory virtual column, it says like enable, manual, and disable if you want to use virtual columns. Right? There is some more reading on this. Optimizer memory aware, true or false. Default value will be true. If you want to force it, if you want to disable it, then you'll set it to false. And you can use it on alter session and system level. Okay. And again, some more reading on this if you want to read some more on that. So how you configure in-memory column store, and there was a new thing came in 12.2, that is dynamic resize. So in release 12.2, it is not anymore static. Prior to that, in 12.1 plus the in-memory patch, it was static. But if you are at 12.2, you should be able to dynamically increase it, but you cannot reduce it. So for an example here, if my current in-memory column store is 250 MB, and I try to increase it, but I was not able to increase it. It gave me some error. And so what I found is it has to be in the multiple of 128 MB. And I was just trying to increase it to 20 MB, so that's why it was giving me an error. The next time I increase in that multiple, and I try to set it to like 388, and it worked. Then again, I try to reduce it, and it gave me an error. So just to prove the point that you can increase it, but it has to be in the multiple of 128, the addition, and you cannot reduce it, right? So if you are using in-memory column store in multi-tenant environment, then how it works? You will define in-memory size parameter on a CDB label, and you'll define in-memory size parameter on PDB label. So if you define it on a PDB label, then there'll be in-memory column store for the PDB. If you have like multiple pluggable databases, and you want to use in-memory column store for them, but you do not have enough memory, you can do an oversubscription also. All right, so let's revisit in memory one more time. You get benefit of memory operations. So if you put something in the memory, you get benefited. Then you get efficient joins. Um, so only needed columns are scanned and filtered in the in-memory columns rather than the whole row. Use Bloom filter scan happens on compressed data. So if you're lucky enough to achieve a Bloom filter, then it will happen on a compressed data. And column memory has a smaller footprint as it is compressed, right? It uses SIMD. So SIMD is single instruction, multiple data. So less CPU cycles to visit more data. That's the SIMD. And then within 12.1, you have a vector group by clause for the in-memory aggregation. So that's also a feature which can show you considerable performance gains. Okay. And there's another slide I got from someone at Oracle, actually Maria. Yeah, and what it says is like using SIMD, you can scan like millions of rows per second, but if you use SIMD, you should be able to scan billions of rows per second. So SIMD itself, Oracle claims that makes things 100x faster. So this is something interesting. Now, how you populate in-memory column store. So at a create time, so you're doing a create table, and at the end you say in memory, and here I said priority critical. I had an option of critical, high, medium, low, or none, and this is a priority, but not the speed. Speed will be defined by in-memory max populate servers parameter, right? So the first one was when I was doing a create table. The second one is again a create table, but I can use certain columns. So I do not have to put all the columns in memory. So say for an example, for an instance, if you have a table where you have nodes or lob or that kind of columns, and you do not want to put them in a large text column, which you do not want to put in memory, then you can create your table like this: in memory, priority critical, no in memory, and those columns comma separated, which you do not want to put in memory column store, right? Okay, then you can do the same thing with the alter statement. If your table is already created, alter table SOE dot order underscore items in memory, and then I'm saying mem compress for query low. So what I'm saying is put this thing in memory, and I'm defining what kind of compression I want to use. Then the next thing I did is I thought let's query and see if it is in memory column store. and no row selected, because it will not start populating unless there is a first access happens. So then I decided, okay, I do not want to wait for the first access, but I want this thing to be populated in the memory. So the next alter statement, I change the priority to critical. If you see here, I changed the priority to critical, right? And it started populating it. And if you see, bytes not populated in MB, it says my table was 278 MB. By the time it was done, in the second run when I ran the same query, in memory size in MB was 69 MB, and bytes not populated in MB was 0. So that means the table was fully populated with the size of 69 MB, wherein the size on the disk was 278 MB. So there was a considerable compression gain. Okay, so how to remove it from in memory? I talked about this parameter in our prior slides. Alter system set in memory force is equal to off. System altered, and you check that the table which was showing here, and this all is in continuation. So the table which was showing here initially is gone. It is there in the in-memory column store, but it will not show you. It will not be used. And then I change the value to default back again, and table is back. So this is an on and off switch, very interesting parameter. So now the last thing was it is back, and I did a query and I see that table access in memory full. If you see here, so my query is using in memory column store. Then another parameter which I used initially, which we discussed initially in the parameter screen, that was in memory query. I said, oh, let's disable it. And I disabled in memory query, and see what happened is it started using index fast full scan. So the in memory scan which was happening in the previous slide, table access in memory full, is now converted to a index fast full scan. That means my in-memory query is disabled. So, and when I enabled it back, you see that table access in memory full again. So in memory column store started, and this is again on and off switch. If you want to show it to your users that in memory is helping you, then you can just do a on and off switch and show it to them, right? So now, so far we talked about what is in memory option, how you configure it, how you populate it. Now, the next question you may ask is, how do I know what table I need to put into in-memory column store? And that's a very valid question, and that's why there are in-memory column store advisors. So there is a mouse note 196.5343.1 which you need to review. And what it does is it will analyze your existing DB workload via AWR and ASH repositories. And it will provide you a list of objects that would benefit most from being populated into in-memory column store. You need to download something from this note 196.5343.1, and then there'll be a ZEF file. You uncompress it, and then you'll see a SQL script that's install instIMADV, and this will input for a temporary or permanent table space. And once you are done with the advisor. If you want to remove it, then there's a cat no IMADD. You can remove it, right? So the first screen which you see after running the advisor um, is this. It's basically it's a report of advisor, and it will tell all the specifics about your database, right? Then one of the section will be workload database usage, and it says like total database time in seconds, total time spent in seconds for the analytical processing, and the total percentage of process analytical processing. So in my database, I had 2% of load was analytical processing, and then it says it give you an advisory like how much in memory column, how big in memory column store you need. So for an example, it says uh, how much it says like if you have 66.5 MB, the estimated analytics processing performance improvement will be 1.2x. If I do it 17 MB, if I do it 70 MB, then they'll be the same. But if I do it 73.89 MB, the performance gain will be 1.4x. And if I do it 200 MB, it'll be the same. So it will kind of tell you like what is the best point where you can or you want to go, right? Then the next thing is what all tables you want to put into in-memory column store. So here it's telling me like what all tables I can put into in-memory column store, and then it talks about kind of what will be the size of these tables in memory column store, right? This will be the size, and this will be the analytics processing seconds, and this will be the reduce. So this was the time database was using. If I put them, then this is the time data which will be using, and this will be the processing improvement factor, and this is the benefit cost ratio. So some neat information it will give you a basis of deciding what you need to put into in-memory column store. Then there's a compression advisor which will tell you how much compression you'll get. For an example, I use like swing bench table SOE.order items, which was 280 MB table, and when I did it query high compression, I got 4.1 compression ratio, and when I did query low, I got 3.8. So you have to pick and choose what kind of compression you want based on what kind of performance needs you have, and compression advisor will help you. And this is the PL SQL block which will give you all this information. So by now we talked about how you configure, how you populate, what are your advisors, and then I'll talk about what are the new features introduced in 12.2 which will help you. So in-memory column store storage index. So storage index is something which you saw in Exadata, but not in, it was not available in Oracle databases until 12.2. And basically what it does is, say for an example, you want to find all sales from the stores with the store ID of 8. And the way it works, it will not go and search for individual block, but the way it works is it works based on the elimination. So the storage indexes, if you see on the right side, it will store a value. Okay, for this memory region, the max and min values are 1 and 3. For the next region, the max and min values are 4 and 7. The for the third one, the max and min value are 8 and 12. For the fourth one, 7 and 15, right? So now when it will start scanning, you go to the first storage region, read the max and min value, says 1 and 3, no, I do not need it. Second, 4 and 8, I do not need it. So basically, rather than searching something, it works based on elimination. It will eliminate first two blocks, and on the third region, it'll find what it needs. So that's the storage indexes. So 12.2 came with another new feature that's called IMCS Fast Start. IMCS Fast Start is like, what if you face a database crash, or you add another no rack node? How you can assure that your in-memory column store gets populated ASAP? And the only way to do that was in-memory column store fast start feature, which was introduced in 12.2. And basically what it does is uh, it stores the in-memory column store information in a physical table space, and in event of a crash, or if you're adding a rack node, it will read it from there. Approximately, that table space need to be a double the size of in-memory column store. Um, There is a procedure dbms in-memory admin fast start enabled, which you need to use to enable this. And in this view, $v in-memory fast start area will show what all in-memory stuff is in the table space. We'll go to the table space. There is some good reading here, in case you want to read further about this. So for an example here, what I did is I had a table which was 69.56 MB, and as soon as I started checking, I enabled in another screen, and I started checking how much space it is taking in that table space. So with the first run, I found 28.25, and with the next last run, I found like 80.25. So my 69 MB table was stored in the table space as 80 MB. So Oracle says it may take up to twice the size, but in this case, it was maybe 15-20% extra. All right. So the new feature in 12.2 came was support for active data guard. We talked about it in previous slides, but what was like, now you can have your in-memory column store on active data guard side, so your queries will be, your reporting will be more fast. All you need to do is you need to set in-memory size parameter on active data guard side, right? And it will start populating in-memory column store on active data guard. There is some flexibility, so you can have a different in-memory column store on primary and active data guard. All you need to do is you need to create a service to access primary, then you create a service to access standby. And when you define, so you create a service to access in-memory column store on a primary side and standby side. Then when you create your in-memory, when you create a table, and so you say like in-memory, and that there is a keyword distribute for service and the service name. So you can say like prod or standby, whatever the service you created, and that way, uh, me system will know from where this need to be retrieved. And then you have an option to create in-memory column store on only active data guard side. So if you do not want to overload your production and utilize this feature just on active data guard, then that is also an available option. So now you created active data guard on in-memory column store on active data guard side. Now another thing you may think is, okay, how do I manage the things at the runtime? if I want to keep something into in memory, I want to phase it out, and the answer is heat maps. So data access uh, 12.2 has an option to implement heat maps, and what it does is data access frequency will be tracked. Data added, removed from in-memory column store is based on the temperature and memory pressure. So how frequently uh, data is being accessed and how much memory pressure we have, based on that it will be decided if the that table will be stored in in-memory column store or will be phased out. Can be user defined too. So you need to set below parameters like heat underscore map on, memory ADO enabled true, and so by default, uh, automatic mode only works when you have a 90% or more in-memory column storage full. So if so, this heat map will not work if it is 89% used. It kicks in when it is 90% or more used. Um, you can change that threshold by using IMADO mem threshold to make it 80% or 70%. I cannot think of a use case, but if there is any, then this is an underscore parameter which you can use. So that was Oracle will decide what to keep, what to phase out. Now, if you want uh, a more granular control, you want to control the things by yourself, then you can create ADO policies. And what it is like, say, for an example, what I'm trying to do here is alter table Anuj ILM add ADO no in memory after 10 days of no modification. So I'm saying if there is no modification happening in this table or this table becomes static, remove it from in memory column. It does not make any sense, but you can do whatever you want, and that's the example here which I used in real life. If the table is changing frequently, you do not want to keep it in memory column store, uh, but if you do this, database will not allow you, will not stop you. You can do this. The next thing is little logical. So if there is no alter table Anuj ILM add policy, no in memory after 120 days of creation. So I created a table. I assume that will be heavily used for 3-4 months, but will not be used. Uh, it will not be used a lot after 120 days. So I do not need to keep it in memory, and I can control that. If someone is not using that table at all, and I notice that there are 25 days past, then I can create a policy like this, that if something is not being accessed for X many days, then you can remove it from in memory column. So that was more granular control, right? So then there were some more enhancements. So if join operations, if you're lucky, you're using a Bloom filter. Uh, so the condition for Bloom filter is it has to have a where clause on a small table in the join operation. And if this is the case, then what will happen is it will evaluate where clause, and based on the result set, it will do a simple scan on the large table. So basically, Bloom filter will convert a multi-table join to a faster scan operation, and that's how it is really fast. But you got to have meet these conditions that there is a join between large and small table, and there has to be a where clause on a small table. Now, if that is not the case, you're doing a hash join, and the way hash join works in memory is, for an example, 12.1, I'm saying do a hash join between vehicle and sales table. So what will happen is it will scan the vehicle table, decompress the matching rows, build a hash table based on the above data, and based on that data on the hash table, it will decompress the matching rows. So it will match the rows first and then decompress. And then it will probe the hash tables using the join column. So that's all need to be done for doing a hash join within in-memory. It's fast. But 12.2 introduced a faster option that was called join group. And the join group is basically if you know that you are going to do a join between vehicle and sales table, you know what column you will be using to join this, right? So then there is no vehicle table scan required. There is no hash table building required, and there is no scanning of a sales table based on the matching rows from the hash. So all these are not required. Row sent to hash join is not required. So database operates on, so in the join group enhancement, database will operate on a compressed data. So in hash join based on a join group, the database uses an array instead of building a hash table. Okay. And how you create is create in memory join group name, and then you say table 1, table 2, column 2 on which you are creating a join. So internally what happens? Basically what happens is, if you remember, um, in our initial slides where I said like there are two pools, compression unit and snapshot metadata unit. So basically you have a metadata stored for a data, and basically those are nothing but the symbols, right? So if I know that I'm going to create a join based on table 1's column 1 and tables 2 column 2, so if I use a same symbol for table 1 column 1 and table 2 column 2, if I use the same symbol, so when I have to do a join, I'm basically retrieving one symbol and I'll be retrieving matching rows. And that's how it works, right? So that's join group. It's a really neat feature and can see some considerable performance gains if you are using this feature. Uh, in memory expression, that was a 12.2, another neat feature. And what it does is, say for an example here, what I'm trying to do is, I have a table with employee ID, salary, and commission percent, right? And I want to calculate employees' weekly salary and I want to calculate employees' annual compensation, but those are not there in the table. So I can create an expression and stored in memory column store as in a virtual column. And there are two processes which are involved for doing that: in memory coordinator process, IMCO, and space management worker process, that is WN. If you're using it, then in-memory expression uses in-memory virtual columns, in-memory expression uses the view. If you notice, like there is an expression and there is an expression, so that's a superset. Are the views which you can use to get more information about it, how it is being used, how beneficial it is for you. Uh, DBMS in memory.ime capture expressions is the procedure to add expression. If you want to drop expression or expressions, then there are two ways: DBMS in memory IME drop expressions. Uh, if you want to drop an individual expression, if you want to drop like multiple expressions or all expressions, then DBMS in memory admin IME drop all expressions. Actually, this is for dropping all expressions. But again, you do not have to do a lot of calculation at the runtime. If you want to calculate weekly salary and annual compensation, those things can be pre-calculated and stored in memory column store as virtual columns. And you can avoid all those calculations and retrieve column data just like that. So that was in-memory expressions. So I am closing to The end of presentation, I think this feature is that 12.2 in memory was introduced in Exadata Flash, in memory format in Exadata Flash, and smart scans get the in memory benefits. So if you're doing a smart scan, which was running out of the flash, it can get a benefit of in memory column store. And the good part is, like, you may have 5 times or 10 times more flash than your actual physical memory. So on Exadata machine, so you can have really big in-memory column store on flash, and it's very easy to implement. All you need to do is say like order table and cell memory, and then it will take it to the in-memory column store on the flash, and you can remove it. On a creation time, you can use uh, create table Mohan, and then the details of the table cell memory mem compress for query low, and that means you can use all your compression options, all your priorities, everything will be used in the same way. But the limitation is if you are using EHCC on, then only you can use it. I think in the next release of database, which is 18, this limitation is removed. Uh, but I still have to check it and test it, right? And if you want to monitor the uses, this is the column which you need to scan cell memory IM scans and see how much benefit you are getting out of it. All right. With this, if you want to learn more on 12C, so they have got really good resources. It's not like the previous documentation which we had on a 9i or 10G or even an 11G for that matter. This documentation is like very improved. They got a lot of uh, video and graphical ways of learning, and so it's really easy to browse through and learn. So I'd encourage you to go to this page and check this out. Uh, there is a special area for the in memory which you can check and get benefit of it. With this, thank you very much. Here is my contact information in case you want a copy of the slides. I think it'll be stored in the APAC website, but if you want the copy, you should be able to send me an email, reach out to me via Twitter, and I can share my presentation with you. If with that, if there are any question, I'll be answering, and I'm here for the next 5-10 minutes. I'll be answering any questions. Okay, so let me check on chat. I see there are. I was told that there are some questions. Let me check what question I had. Okay, so I'm still trying to. Still trying to browse through and figure out where is the chat. Okay, so the one question was, if the database I have mostly write intensive, do you still recommend in memory? And answer is no. Uh, so in memory is an expensive option. I do not actually. I'd rather than say I'm not allowed to talk about the price or dollar value. So if your database is doing mostly write, then it's not a good thing to use. You might want to check the new thing came um, in 18C, but I am not up to speed with that at this moment. But 12.2 in memory, if you have some analytical workload, then it may be useful for you. Can I use in memory advisor without actually enabling it? Yes, answer is yes. What best compression method would you recommend? So you have to pick and choose. Um, based on your needs. You might want to check with the query low, then query high. If you think that's not being, so you have to use that compression method and see the benefits, then change it to another and see the benefit, how much compression you are getting, how much query speed is increasing or reducing. Based on that, you have to pick and choose. So the one more question I got here was, suppose we have we I have suppose without IMCs currently we have 100 GB defined as a SGA, how much we need to keep the SGA for in-memory column store? That's what the question is. And answer to that is, you can start with a slow. Uh, if you think that you may need another 100 gig for in-memory column store, you do not need to allocate everything. Just keep your SGA target to 200 gig, and then give a small chunk, and you should be able to increase it dynamically as uh, and reach to a point which suits best of your needs. Okay, so I don't think I have any new question. Um, so we got another 4 minutes here, and I'll be happy to answer any question. If you do not get chance to send question now, on the screen, you can reach out to me using my email address, or you can connect me on LinkedIn or Twitter, and I'll be happy to answer any question. All right. Um, so if there is no new question, then we will disconnect at this point. Thank you very much for joining, and keep in touch. I'll be glad to share some more if you have any questions. Thank you, everyone.